All right, everyone. So now we're going to look at how the kidneys can help us out in maintaining the correct level of hydrogen ions in each compartment, in each fluid compartment. All right. So the kidneys, again, helping us out. They act a bit slower, but they do kind of help us out. Now, the way that they help us out is by manipulating bicarbonate, okay? So bicarbonate ions in the blood. So the kidneys can either reabsorb bicarbonate molecules or excrete. So the kidney either grabs bicarbonate molecules from the urine, puts them back into the blood, or grabs bicarbonate molecules from the blood and puts it in the urine to get rid of it, okay? Let's have a look at this. If your blood pH rises, the kidney gets rid of bicarbonates, okay? Moved from the blood and into the urine. And the hydrogen ions are kept in the urine, okay? When the pH falls, so you've got lots, so in this particular instance, you don't have enough hydrogen ions, bicarbonate ions are moved from the blood. When the blood pH falls, means that you have too many hydrogens, because too many hydrogens means an acidic environment, and in the pH scale, acidic environment is a low number. When the blood pH falls, bicarbonates are moved from the urine back into the blood, and we also get rid of hydrogen ions, okay? Hydrogen ions. So what you want to do, in order to have the right pH, you need to have the right number of bicarbonates and the right number of hydrogens, okay? So that's going to contribute to pH. So your kidney is going to deal with the bicarbonate ion part, whereas the lungs are responsible for dealing with the carbon dioxide part of pH, okay? All right. So we do have some abnormalities of acid-base balance, and as I told you before, you can be acidic or you can be too alkaline. Can you see here? It's all about how much carbon dioxide you have versus how much bicarbonate you have. And all of these imbalances have a different name, okay? I guess what you need to understand is that you will learn about this more in your other subjects, because I'll just give you an example. If your blood pH is less than 7.35, so your blood in your arteries, you are in acidosis, okay? This can happen between you don't have enough bicarbonates in your blood, or you have too much carbon dioxide in your blood. Now, if you have too much carbon dioxide in your blood, that means that's called respiratory acidosis. So what happens is that your kidneys help you out. So your kidneys compensate for respiratory acidosis. If the problem is with the bicarbonates, so your kidneys aren't working, then that's called metabolic acidosis. And then your respiratory system helps you out. So the respiratory system and the renal system help each other, and one picks up the slack if the other one is not working, okay? Essentially, that's what happens. Okay, and that's the end of that. So for this particular instance, your arterial blood pH, you need to have the right balance of bicarbonates and carbon dioxide. I think it's 20-1. You have to have the right amount of bicarbonates and the right amount of carbon dioxide in your blood to maintain the arterial blood pH. If there's something wrong with the bicarbonate part, the kidney will help you out. Can give you more or get rid of some. If there's something wrong with the carbon dioxide part, then the lungs are responsible for that part. They will give you more carbon dioxide or get rid of it for you, okay? So the kidneys and the lungs work together, but they're all responsible for different parts. The kidney is responsible for bicarbonate, the lung is responsible for carbon dioxide, and you have to have the right amount. 20 bicarbonates to 1 carbon dioxide. You can't shift that balance, because if you shift that balance, your blood pH will change, and we don't want that to happen. All right. Yay, we finished that.